Hello, and welcome to this important session where we will be exploring the critical concepts of change management, configuration management, and patch control. These processes form the backbone of maintaining secure and resilient IT environments by ensuring that changes to systems, applications, and infrastructure are made in a controlled, predictable, and secure manner. Without these practices in place, organizations are vulnerable to unnecessary risks and disruption. Let's dive into each of these processes and understand their significance in cybersecurity. Change management is a structured approach to managing changes to an organization's IT infrastructure, applications, or systems in a way that minimizes risk and ensures stability. Changes can come in many forms: software updates, system upgrades, hardware replacements, configuration adjustments, or even changes to user access controls. Each of these changes has the potential to introduce new vulnerabilities or affect the operation of critical systems. Therefore, change management aims to provide a controlled environment for implementing these changes, ensuring they are thoroughly tested, documented, and reviewed before being deployed. The change management process typically begins with the identification and documentation of a proposed change. This may come from various sources, including the IT department, developers, or external vendors. The next step is to assess the potential impact of the change. This involves reviewing the change to ensure it is necessary, determining its impact on security, functionality, and overall system performance, and evaluating whether it might disrupt other systems or processes. A formal approval process follows, in which stakeholders, including security teams, system owners, and sometimes senior management, review and authorize the change. Once approved, the change is implemented in a controlled manner, often in a staging environment that mimics the live system. Testing is critical during this phase to ensure that the change does not introduce new issues or vulnerabilities. After successful testing, the change is deployed to production, and monitoring continues to ensure that it does not cause any unforeseen problems. Finally, the change is documented in detail, including the reasoning behind it, the steps taken to implement it, and the outcome. Documentation is essential for future reference and for ensuring compliance with internal policies or external regulations. One of the key principles of change management is the rollback plan. This refers to the ability to revert to a previous stable state if the change causes issues. A rollback plan ensures that any problems that arise during the change process can be quickly addressed, minimizing downtime and disruptions. Proper documentation, monitoring, and testing before deployment all help ensure that rollback is a straightforward process if needed. Configuration management, on the other hand, is the process of establishing and maintaining consistency in the performance and functionality of systems, applications, and networks over time. This practice is designed to control and track the configuration of hardware, software, network devices, and systems to ensure they are securely and efficiently operating. The goal of configuration management is to ensure that all components of the IT infrastructure are correctly configured and maintained in alignment with organizational policies, security standards, and industry best practices. Configuration management includes the management of both software and hardware configurations. Software configurations involve ensuring that applications and systems are installed and configured according to security guidelines, while hardware configurations involve ensuring that devices such as routers, firewalls, and servers are set up to meet performance, security, and availability requirements. Configuration management also plays a critical role in vulnerability management. By establishing a known, secure baseline configuration, organizations can quickly identify deviations from the baseline, which might indicate security weaknesses or misconfigurations that could be exploited by attackers. The process of configuration management begins with the creation of configuration standards, which define the optimal settings and parameters for each system or device. Once the configuration standards are established, they are applied across the organization's infrastructure. Configuration management tools, such as Ansible, Puppet, or Chef, are often used to automate the process of applying and maintaining configurations, ensuring that systems remain compliant with established standards. One of the major benefits of configuration management is its ability to track changes and detect unauthorized alterations. By continuously monitoring the configurations of systems and devices, organizations can identify deviations from the baseline and address them before they lead to security vulnerabilities. This also supports incident response efforts by providing visibility into configuration changes that might have been made during a security breach, helping to identify the source of the compromise. Patch control, also known as patch management, is the process of managing and applying updates to software and systems to fix known vulnerabilities and improve security. Patches are updates released by vendors to address flaws in software, operating systems, or hardware that could be exploited by attackers. Patch management is an essential part of any security strategy, as unpatched systems are prime targets for cybercriminals. Ensuring that patches are applied in a timely and controlled manner is crucial for maintaining the integrity and security of systems. The patch management process typically starts with the identification of available patches. This is done by monitoring vendors' websites, security bulletins, and automated patch management tools for new patches related to the organization's software and systems. Once a patch is identified, the next step is to assess its relevance and impact. Not all patches need to be applied immediately, as some may be minor updates or non-critical fixes. It is important to assess whether the patch addresses a critical vulnerability or if it might introduce any compatibility issues or disruptions to existing systems. After the patch is assessed, it is tested in a controlled environment to ensure that it does not cause any problems with existing applications or systems. Testing is essential to minimize the risk of system downtime or performance degradation. Once the patch is validated, it can be deployed to production systems. Automated patch management tools can streamline this process by ensuring that patches are applied consistently across all systems, reducing the burden on IT staff and ensuring that no systems are left unpatched. Another key aspect of patch management is prioritization. Not all patches are created equal, and some patches address more critical vulnerabilities than others. For example, patches that fix vulnerabilities that are actively being exploited in the wild should be applied as soon as possible, while less urgent updates can be deferred. Patch management tools can help automate this prioritization by categorizing patches based on their severity and impact on the organization. Finally, patch management includes the documentation of patching activities. Detailed records should be maintained to track which patches have been applied to which systems, when they were applied, and whether any issues were encountered during deployment. This documentation is critical for compliance purposes and helps organizations demonstrate their commitment to maintaining secure systems. To wrap up, change management, configuration management, and patch control are foundational elements of an organization's cybersecurity strategy. Change management ensures that changes to systems and infrastructure are made in a controlled and secure manner, reducing the risk of introducing vulnerabilities or disruptions. Configuration management helps organizations maintain a consistent, secure state across their IT environment, while patch management ensures that systems are regularly updated to address known vulnerabilities. Together, these processes help organizations maintain a secure and resilient IT infrastructure, reducing the likelihood of successful attacks and ensuring that systems are operating at their highest level of performance and security. By implementing and adhering to these practices, organizations can strengthen their defenses, protect sensitive data, and maintain a robust security posture in the face of evolving threats.